We're going to be doing 2 demos today in order to show you what you should be checking when you're signing transactions. The first demo will be sending ETH from a safe wallet to some other address. And then we're going to be doing a second demo where we're sending USDC instead, because ETH is a native asset and USDC is basically an ERC20 contract on the blockchain. There will be some differences to take note of. Before we do that, let's introduce our stack. So this is the Safe UI. We will be connecting it to the Rabby wallet extension, browser extension, which will in turn be connected to the Keystone hardware wallet. And on this wallet will be loaded the EOA address that owns the Safe wallet that we'll be transferring funds from. The first thing to check will be the Safe UI. And then the second thing will be what we see on the Rabby wallet. And the final thing will be what we see on the Keystone wallet. There's a lot going on. And so then I created a spreadsheet where we can put in all of the data that we're seeing and validate them after we've input all the data that we can check. And then at the end of the day, we'll be matching them to see if they all match, in which case we should go ahead and sign. And if not, we should try and see if anything went wrong. Let's move over to the template spreadsheet. The first thing we're going to want to do is to enter the details of the transaction that we intend to perform. So we will be working on the base network. Let's punch that in. Let's punch in the EOA signer address. I'm going to put the full address on the right and then put the leading digits and the ending digits here. You should really be checking a lot more digits than this. I don't know, maybe make it 15 digits in the front, back, and in the middle. If you only check the front and the back 6 digits, you're definitely going to be subject to what we call transaction poisoning attacks, where malicious actors can generate an address that looks very similar to the one that you intend. And if you don't check the full address, you might very quickly skim over and think that it is the address that you intend. So just a note here for demo purposes, I'm just going to check just the front 3 and the back 3, but you should not be doing that for real transactions. Let me now put in the Safe Wallet address and the recipient to address. Let's say we want to transfer 0.123 zeros and 2 ETH. Now, this is the amount that we're planning to transfer in terms of ETH, but the units that we need to use for making a transaction is WEI. And so we can go use an ETH converter to plug in 0.0002 ETH to get the many zeros that we need for the units in WEI. And this is eth-converter.com. There we go. And to make it easy to see, let's convert it into a number with commas. 1, 2, 3, 4 commas, and then 200. If you'd like, you can put in nicknames for the addresses too, so that it's easier to understand what you're doing. But for now, I'm not going to do that. All right, so we've set up all the information we need to make this transaction. So let's go ahead and look at our Safe UI. This is our Safe account. We want to send tokens to this address, which I have saved, so it's more convenient. We want to put in 0.0002 ETH. Note that we put the amount of ETH here, not in units of WEI. And the way we know that is because if you look on the right here, the amount of ETH I have in my account is reflected in full round units of ETH. All right, the transaction is ready. Let's open up advanced details. We have transaction data in this section and then hashes in this section. I'm going to go ahead and copy these over into our spreadsheet. So the 2 would be that right here. I'm going to pause the video and just fill everything in. I've now filled in all of this data, which we very simply copied over from this section of the Safe UI. Now let's look at what else we can do. They've put here a Tenderly simulation button. Let's hit simulate to get our simulation. Simulation report is available. Let's click on that. Basically, on Tenderly, we're going to be getting another source of data to check. And we want to put it in this column. Just a quick explainer of what Tenderly does is it takes your transaction, which is just in draft form. It doesn't exist anyway. It takes the data and it plugs it into the state of the blockchain and tells you what would happen afterward. So for example, if you look at state here, it'll show that these addresses will start with this balance and end with this balance. That's why it's called a simulator. It can look really overwhelming. To me, it honestly was the first time I started using Tenderly. But essentially, for our purposes, we only need to look at the data from 2 sections, the summary tab here and the events tab. The events tab is a little bit more straightforward to review, so I am going to start copying over the data. And as you can see, it's got the data in very similar format as the Safe UI. So we have the 2 value data, gas information, and we're going to copy that over right now. So copy the 2, put it here, and I'm going to pause the video again while I fill this in. I filled in the transaction data. Note that nonce isn't available in from this Tenderly source. I wanted to show you where we get these hashes. It's not that straightforward. Let's go back to Tenderly and hit the summary page. Now, you're going to have to do some Control F or Command F to find what we need. So I'm going to do search for domain separator. Domain separator here, the value is actually the domain hash. So I'm going to copy that and paste it here. And then for the message hash, they call it data. Here. It's not data hash, it's data. So if I click that and copy the value, paste it over. This is why somewhere in the UI, they or Safe should really have like a helper text saying, you know, click here to figure out where to find these hashes. Now, finally, data hash is actually the SafeTX hash. I'm going to paste here. And it's looking good in terms of being very comparable. Yep. However, if you look closely, you'll see that the message hash actually is composed of 0x1901, and then the domain hash, which we know from here, followed by the message hash that we see in the Safe UI. But I don't know of any other way to get the message hash cleanly from Tenderly, so this is how we're going to do it. Just truncate the last third of the information in data. Again, this is where any helper text or a blog linked to right in the Tenderly UI would be helpful. Finally, we're going to hunt down balance changes. We want to see for the from address what the change in ETH is, and likewise for the to address. Conveniently, it is right here above all this messy mass of data. We can see that the safe address E60, which is somewhat misleadingly labeled receiver here, it's the receiver of the instruction, the message for signing, will be seeing a 0.002 minus change, a reduction in the ETH balance. But remember, we need to convert that to units in way. The other way you could find this number without having to do that conversion is under state. You can basically look for the safe address, pick the ending balance here, minus the beginning balance. There you go. We have 4 commas and 200 in parentheses, meaning a negative value. And then we're going to do the same for the 9B1 address, which is the recipient. The ending balance minus the beginning balance. There we go. These two numbers matched. All good. So we're actually done putting in the information we can get from Tenderly, but there is one thing I wanted to point out so that you don't get confused, because I was. If you look at the header part of the simulation, you notice details like value is 0 ETH and nonce is 4, which is surprising because we thought we were transferring ETH and we thought nonce was 8. The reason for this is Tenderly takes the point of view, owns the safe wallet. EOA, this is the transaction that it will be signing. On the other hand, on the safe UI, you're obviously taking the point of view of your safe wallet. And this would be the 8th transaction that we're performing. It is slightly confusing that way, but don't be thrown off. All right, so far we have relied on Safe to provide the hashes for us and Tenderly to provide the hashes for us. What if we want to generate them ourselves? What we would use is a tool called the Safe Utils tool. There's a version of it hosted by OpenZeppelin, and it is a fork of Pascal's Safe Hashes CLI only tool. And essentially what we can do is we can enter our transaction details and have the hashes be generated for us. Now, using safeutils.openzeppelin.com assumes that the service is safe. Alternatively, what we can do and what I have done is gone to the OpenZeppelin Safe Hashes repo and run the program locally. So I've done all of this, and now on localhost on the port 3000, we're going to be entering this data to find our hashes. So let's go ahead and select base and the safe address. Nonce would be 8. The recipient address we will need to enter here. And value and way, let's go ahead and copy what we had before. Copy this, and get rid of the commas. Data will be 0, and the operation left at call 0, the default. All of this gas information was left to 0, so just leave it. Calculate hash. All right. Let's copy all of this over. So safe tx hash be here. Domain hash here. And message hash here. This is okay, but these two are not what happened. Guess what we did, or I did. The 2 address was wrong. I was sending it to myself, back to the safe wallet. So let's fix that. There we go. 9B1 is what we expect. Continue, calculate. Copy the safeTX hash. And I don't believe domain has changed, but the message did. There we go. Now it's fixed. I was going to delete that error part, but I thought it would be good to leave it on there so you know that if anything's different, then the hashes will be different. We're done with the safe utils information gathering, but before we go, I want to show you one thing. We left the calculation method at the default, which is manual input. It's basically the process of us manually inputting transaction data. The other way to do it, if you select the drop-down menu, is to go to the Safe API, use the Safe API. So if you tell the Safe API, I'm on base, and this is my safe address, what is the transaction that's saved as the 8th nonce? And it there's an error here because I believe you have to have at least one of your signers sign before the transaction is real and they can pull it from their database. This is obviously not a viable path if you're the only signer, like in this demo. But if you were one of few signers, then this would be a way to check as well without having to manually input. So now we're ready to check our software wallet. Let's go back to our safe UI. And we already checked all this data. We checked the simulation. Now we can hit continue. This screen is, I believe it's new since the Bybit attack, where basically they want to emphasize that you got to check all of this data. And they provide a blog post where they provide specific instructions. It's all very text-based. I wish they had like a GIF or a something a little bit more interactive. But anyways, it's there. It didn't used to be there. And they also suggest using safe util, which we already have. They also make you sign this checkbox saying what I'm signing is irreversible. And I believe it's new. So let's go ahead and click sign. You can see Rabby is showing me this data. We can see what chain we're on, which multi-sig address or wallet address we're using. And this is the type data that we are signing. I just wanted to comment that it can be confusing because Safe calls this a transaction, sign a transaction details. But then in Rabby, they choose the nomenclature, the lexicon of sign type data. I wish, between all these wallets and UIs, they would make it consistent so that users aren't confused. But I'm going to copy over the same transaction data. Or we assume it's the same, but we have to check. So I'm going to copy all this data over into the spreadsheet here. Go to address over here. I'm going to pause the video and fill in the rest. It's done. Let's go back to our notification from Rabby, and we're happy. So we're going to hit begin signing process, and this will send us to our hardware wallet. On my hardware wallet, I'm looking at something that looks like this. This was from a previous similar transaction, so the exact data is not the same, but essentially this is a type of data that you'll see. And you'll notice that they use the word message. So between the 3 different UIs, we're seeing 3 different terminologies. Transaction, type data, and message. Not ideal, in my opinion. And obviously, we can't copy paste this from our hardware wallet. What I'm going to do is to basically copy the leading values of each. So I'm scrolling through my hardware wallet now, and I am seeing a lot of zeros. So I'm 0x here, 0 call, here 0 for the gas related options. Nonce is a clear 0. And then for the intended recipient, we're looking at here 0xEDE and all the way to 9B1. I stress again, you have to check a lot more digits, maybe 15 digits, because of transaction poisoning attacks, where you might be copying over the wrong address. For the amount, the value, we're gonna have to hope that we're counting the right number of zeros. So I see 2 and 1, 2, 3, 4, 5, 6, 7. You know, I give up. It's really hard to see on the Keystone because they don't add any commas. And I'm just gonna don't do this in a real transaction, but I'm gonna assume it's the same. Let's reformat these two. There we go. We aren't able to check the hashes because it hasn't yet been enabled in Keystone, but from what I understand, very soon after the Bybit attack, after feedback from Patrick Collins, they said that in one of their future updates, they will be adding hashes. So I'm excited about that. I did have the intention of demoing the Ledger Flex, but, and the reason for that is they do show the hashes, but I believe something changed in the last week or two where there's an error path where that doesn't happen. But I have very high confidence it'll be fixed. In any case, we have checked a number of data sources. Now our job is to refer to the final column. And our job is to eyeball everything in the same row, and see if they match. So this matches, value matches, everything seems to match. And this matches our expectation that the amount transferred would be 200 and then 4 commas of weight. So yep, we are good to go. Basically, we can go ahead and sign the transaction on the hardware wallet. And be careful to not sign your hardware wallet until you have done this check. With our ETH demo, we're going to move on to our USDC demo. Before we dive into our USDC demo, I'll just call out that we will be demoing 2 new tools, a transaction, basically a call data decoder, and the cast tool, which will help us generate call data so that we don't have to trust the call data that we're shown. Remember that in the ETH transfer, all call data was 0 because there's no message, no data that needed to be passed in. Whereas when we're interacting with a smart contract like the USDC ERC20 smart contract, there will be call data that we need to sign. I'm going to go ahead and fill in the basic transaction data like before. The only new line here is the ERC20 or USDC smart contract address. And the way we find it is we look up base scan, since we're talking about the base deployment, base scan USDC. And here's the first result. Let's just sense check that this is the right one. There's a large amount of USDC, a lot of holders. The token contract is here. And it tells us it's a token with 6 decimals. So I'll show you what it means in a bit. We'll put in the contract address here, the full address, and partial address here. Let's say we want to transfer 1.2 USDC, so $1.2 USDC. What 6 decimals mean is that for every dollar you add 6 zeros afterwards. So if we have 1, 2, we'll add 5 zeros. There we go. Let's add commas for clarity. I'm going to pause the video and just fill in the address as before. Now let's go to the Safe UI and initiate a USDC transfer. New transaction, send tokens. Let's copy our to address and put it here. And we were looking for USDC, and we're looking at 1.2 USDC. Hit next, and our transaction is ready. You'll notice that my nonce is still at 8 because I basically did not complete the previous ETH demo. And so we're still at nonce of 8. Let's hit advanced details. What we see here is very similar to what we saw before. We have a section on transaction data with the to and values and the nonce, and we have a section with transaction hashes. What's new here is the first part here. It says call transfer on fiat token proxy, a to address, which is our intended recipient, and a value, which is the amount, $1.2 USDC expressed in 6 decimal places. So this part we understand, we agree with. The first line basically says that the transfer function is being called on this contract. And the contract doesn't say USDC, but if you click on it, you'll see in the URL here, it's exactly the same contract that we saw earlier. This is USDC. You see the section token tracker. If you hit this page, we'll go to exactly the same page we looked at before, which is we had this high amount of market cap with a couple thousand holders, a couple million holders. So like before, we're going to copy all this into the spreadsheet and also this part. So I've added a section here that did not exist for the ETH section. Function is transfer. On the contract being called, here we go, is the USDC address, which is again named fiat token proxy here, 913. To address would be this 9B1, and value is this number. Now the transaction data is slightly different than before because the to address is not the recipient's address. The to address is the smart contract address because we're sending this message to this signed message to the smart contract. Let's paste that here. And value is 0 because no ETH is being sent. This value here only refers to ETH being sent. Let's put that in here. And data now, it used to say just nothing, 0x or 0. And now it says a string of things. We're going to copy that over. This is our call data. Everything else is the same. You have operation 0, gas data 0, and nonce 8. I'm going to copy all this over and pause the video. I filled in the information from the Safe UI. Let's go back and simulate the transaction on Tenderly. The format is very similar, so I'm going to pause the video and just copy everything over. All the data on Tenderly is now imported into our Tenderly column. The next thing we're going to move on to is a transaction decoder. What we can do to double check is to take this call data and put it into what we call a transaction decoder by rimmeisner.dev, I believe one of the co-founders of Safe. If you put in your call data here, hit enter, we'll see that this call data tells the smart contract address that it wants to call the transfer function and passes in the recipient address and the amount in 6 decimals. So we verified that it called transfer, and this was the amount that we saw. The opposite way of thinking about call data is to say, how do I know that all of my intended inputs results in this call data exactly? So you're checking from the opposite direction. And you can actually generate call data yourself using a tool called Cast, which is part of the Foundry toolkit created by Paradigm. And they show a function you can use called Cast Call Data with this pattern. So you put in quotes the function pattern and the actual parameters, like the actual address and the amount. We know the function is transfer, but just to be very sure that we have the formatting correct, what we're going to do is to go to our token page on Basecamp and look up a transaction that says transfer. There are a lot of different transaction types under method. We want one that says transfer. If we click one of these transfers, we'll see the format that the function took. So it says transfer open parenthesis address to unit 256. So we're going to copy that and put it here. So cast call data, paste. Notice that the format was type only. So let's put quotes around it. And I'm going to paste the to address. And the amount. I'm not sure if we put down this 6 decimal format or just 1.2, but let's YOLO it and give it a shot. Oh, sorry, I forgot to get rid of the commas. 4F80. Let's take a quick peek. Oh, 4F80. I think we're right here. So copy this call data and paste it here. Eyeballing this, it looks pretty sweet. Nice. So we've generated our own call data. I'm not going to go through the Safe utils again, nor the hardware and software wallets, because nothing's changed from the ETH demo, the ETH transfer demo. So the only homework now is to see if all of these match, and if they do, you give it a green yes, and then we're done. Thank you very much for watching, and all of the websites and resources that we use are on the GitHub repo or show notes wherever you're watching or listening to this. Thank you very much, and feel free to pass me feedback in any of the platforms.